we're using this in some of my research in actually looking at what happens in conversations during CBIT therapy. And we can do things with AI now, like be able to say, okay, were there words spoken? What were those words? What was the content of the words? What was the valence? Like, was it positive, negative, or neutral? So we are starting to look at vocal tics, and what, it's interesting is there's sort of this like semi, in the weeds argument about like, are there actually vocal tics, or are vocal tics just motor tics of vocal areas, right? And so we're also starting to notice that a lot of vocal tics, we can pick up on these subtle motor movements without even having to listen to the audio. So I think when we combine the two, we're going to be able to do it.
Welcome to The Uptick, brought to you by the New Jersey Center for Tourette Syndrome and Associated Disorders, empowering children and adults through education, advocacy, and research by sharing the stories and experiences relevant to the TS community.
Hello and welcome back to The Uptick. Today I'm speaking with Dr. Christine Conelea. She's a PhD research psychologist at the University of Minnesota's Department of Psychiatry and Research Sciences. Her team is at the forefront of a lot of really groundbreaking research spanning Tourette, OCD, and anxiety. She's playing a pivotal role in advancing our understanding of tic disorders and creating new diagnostic tools and treatments. Dr. Conelea, how are you today?
I am really excited to be here. Thank you for having me.
Yeah, excited to have you on The Uptick. So many things we could discuss here and dive into, and your research spans all these areas. One I wanted to dive into initially is just one of the big challenges we have in the tic disorder space, as you know, is access to diagnosis and long delays in diagnosis that many, particularly children, face. I know your team's been working on some exciting projects to improve this. Can you share a little bit about what you're working on?
Yeah, and as you're right, this is diagnosis, and access to diagnosis is a huge problem. We know that it can take between 3 to 10 years between when tics start and when folks get a diagnosis. And then we know there are lots of added challenges of, finding a professional who understands tics, who gets the diagnosis, who understands the comorbidities. So it's something we have heard a lot about from the Tourette community, is this need to improve access. And so what my lab has been interested in is sort of asking the question of whether we can leverage some emerging technologies, primarily around the computer vision space. So being able to identify tics in video is something we have done for a long time in the research lab. So for it's 15-ish years that I've been doing this now, more than that. I think 20. We have been using, in our lab-based experiments, video recordings of participants to understand what kinds of factors impact how often tics are happening, how well people can engage voluntary control over tics, but it's super labor intensive. So in my lab, we're spending, for like a 3-minute video clip, it's about an hour to really precisely use computer software to code when all the different tics are happening, because they happen a lot. So on average, our participants have like 8 tics a minute. That's the average, but some folks have a lot more. And so we've always been like, it's such an interesting feature of tics, is that we can see them. Can we use this to actually help improve diagnosis? And so we began collecting data, the Tourette conference sort of in our lab, and whoever was willing. And we're able to successfully get a grant from the NIH to scale this project up. And so we had an initial study where we looked at videos we had from participants in the lab and showed that we could train computer software to identify eye tics. And We focused on eye tics because 98% of people with Tourette's have them. So we thought, let's start with that.
It often also starts with eye tics in many cases. I think one of my very first tics was an eye tic. So that makes a lot of sense to start there.
Yeah, super common story. That's often, you're right, the first one. And so we were able to show that we could train an algorithm to detect that. We published that finding, and now we also wanted to get past the geographic barriers that I talked about. So we thought, like, instead of just having people who can drive to my lab in Minnesota, how do we make this accessible to everyone in the world? And so we have developed an online research platform where folks can just join the study from anywhere they are, at least in the US right now. We're working on international as well, and be able to participate and share with us brief videos so that we can really build a tool that represents a broader range of the Tourette community, especially folks who aren't able to make it or participate in in-person studies. And so the goal, my dream really is that someday we will have a way for folks to show up in a provider's office anywhere they are, do a quick video, and then have the software be able to say something about, like, yeah, this person probably or maybe has tics. Let's get them to the right next step for them.
Wow. And, a couple points there. One is that to our listeners, if you're interested in taking part in this research, we are looking for more, if we're going to try to, basically we need lots of video content of lots of people ticking. So the more the merrier for signing up for this. Where can they find, more information on this?
Yeah, that's great. Yeah, we're looking to get 1,000 people, which is really exciting. So there's information on my lab's website, which is ticlab.umn.edu. And yeah, you could do it all from the comfort of your own home, on your phone, on your device. And again, like, I want to emphasize too how much we're doing this in partnership with the Tourette community. We have a patient advisory board who has been at every step of the way with us. You can see who they are on my website, but really helping to make sure that we're doing this in a way that is thoughtful and responsive to what the Tourette community is looking for in terms of this diagnosis access.
Yeah, that's a theme I've heard echoed in a lot of what you've shared. Just speaking with you, now and our last time we spoke, just like the importance of making sure the research we're doing is what the community is looking for, and things that we're hearing from them in a clinical setting, and kind of marrying the clinical and research academic sides to make sure that we're going after the right things. It's interesting if we have this giant compository in the end of all these videos of people ticking, and then the algorithm can learn, like, what these minute little movements and stuff, and what what a tic looks like. I guess I know the answer to this question, but I would love to hear you kind of elaborate on it. But is the hope that it would be better than the human eye, like better than a doctor in detecting a tic? Or are there other benefits too around, like, why we might want to have someone go in front of a screen and get their tics detected that way, as opposed to like a GP or a pediatrician detecting it?
Yeah, that's a great question. And our intention is not to replace clinicians. I'm a clinician. I know how that feels.
Of course.
So I'd say a few things. So first, there aren't that many clinical specialists in Tourette's, and that's often a big reason for this gap in diagnosis. Most pediatricians at best maybe have one lecture on Tourette's. Wow. And so we expect a lot of our clinical providers, and being able to have tools that help them more rapidly get to the right diagnosis, I think is a welcome topic in the field. And so I think of it again as this aid. The other thing we know is it's pretty tough. So I think about this too in terms of other domains of medicine. Like, let's say you have a fever. Like, you can take a thermometer and take your temperature and get a quantitative, like a number readout of your temperature, right? You can take a medication, you can redo your temperature, and you can tell, did the number change? The challenge we have when we talk about treatment for Tourette's is we don't have a thermometer, basically, right? We're kind of at the level of like your mom putting her hand on your forehead. It's like, I think
Right.
it's better,
There's not
right?
like an objective reading with a data on it and a number. Yeah.
Exactly. And it's really hard. We know that it's tough for people to be accurate in their reporting of their tics because they happen so much, and so when we do both, when patients get treatment and when we do clinical trials of like new treatments, we've been judging whether they work or not entirely based on a subjective report. And so part of our hope also is like, can this be a tool for those kinds of treatment decisions and trials to really objectively understand better, like, okay, yes, we know that this new treatment produces this % decrease in tics as they're objectively rated. And then the third thing I'll say is, a lot of us also have interest in understanding, like, what are the relationships between tics and the brain and between tics and people's experiences and the environment. And as a scientist, like, whenever you have questions like that, what you really want are good measurement tools. And I think we've had a lot of really important questions come from the community that we've kind of been stuck on because we're like, we can't, super measure this. So for example, I'm working with my close colleague, Deanna Green at UC San Diego, to actually have, when people are in the MRI brain scanner, using video recordings to measure like exactly the precise millisecond when tics happen, so we can really actually go back and look at like what was happening in the brain that led up to that. And so it's like those kind of tools that we've just been lacking that I'm hoping this can sort of help fill that gap.
Really groundbreaking stuff, like what's actually going on in the brain when I get the urge to tic or when I do my tic. Can the video protocol, will that also work for vocal tics? I can imagine those being just very complex with regard to how you, I don't know, a lot of things. But is the focus right now motor tics, or are we're including vocal recordings of vocalizations as well?
Yeah, so this first part of our project, we're focused on motor tics, mostly of the like shoulder up, because we're kind of starting there with like how we're sort of detecting the face and head, but we're starting to work on vocal tics. And so there are ways we can use AI and different machine learning approaches to do things like tell us about the acoustics of the voice. So, how pitch and frequency and volume are all changing. We're using this in some of my research in actually looking at what happens in conversations during CBIT therapy. And we can do things with AI now, like be able to say, okay, what is, were there words spoken? What were those words? What was the content of the words? What was the valence? Like, was it positive, negative, or neutral? So we are starting to look at vocal tics, and what, it's interesting is there's sort of this like semi, in the weeds argument about like, are there actually vocal tics, or are vocal tics just motor tics of vocal areas, right?
Okay.
And so we're also starting to notice that a lot of vocal tics, we can pick up on these subtle motor movements without even having to listen to the audio. So I think when we combine the two, we're going to be able to do it.
Wow, that is fascinating stuff. And to our listeners, check out the site. And if this is something that you're interested in, please, we encourage you to get involved in the research. It can be done virtually anywhere in the United States. What are some of the other areas of research that your team is on? I know you have a number of ongoing studies right now. Would love to hear about some of the other stuff in the pipeline.
Sure. Yeah. So we have a couple other studies looking at CBIT. So I'm sure a lot of folks listening are familiar. Comprehensive behavioral intervention for tics, the first line behavioral treatment for tics. It's where I got started in Tourette research world, was working on the original CBIT trial as a grad student.
Oh, that's fun.
In Doug Wood's lab. Yeah, it was what got me into all of this. So it's really fun.
That was going to be my next question, was how you got into the Tourette research space. So absolutely.
Yeah, let's do the journey. When I wanted to go to grad school, I did psychology in undergrad. I knew I wanted to do behavioral treatments, and I liked kids and teenagers. That was sort of all I knew. And then through some lovely connections, I heard about Doug Wood's lab. I applied, And I got in, which was very nice. And at the time, Doug was working with colleagues at a few other sites to do this multi-site randomized trial of what we now call CBIT. And so it was the first large scale trial to really look at how effective is CBIT in improving tics and other related symptoms that people with Tourette's experience. And so my job was I had this office in a dark basement that flooded every other week.
It's a classic early career. You're
Yeah.
starting low guy on the totem pole, work your way up kind of story.
Exactly. Crawling out to see the sun once in a while. And so, my job was to be that first point of contact for, participants and families that were interested, and kind of helping people go through the process of the study. And in that, I just really felt so connected to the Tourette community, and to sort of seeing firsthand how, complex and challenging experiences can be, how insufficient our treatments were at the time. It was mostly Haldol and risperidone, not great. And I also really fell in love with just the scientific community in the Tourette space is really awesome. Very, people are very wise and generous and inclusive and come from lots of different disciplines neuroscience, psychology, social work, nursing. And so I got really interested in that, and then I just stuck with it. I expanded a little bit to learn more about OCD, since it's so commonly co-occurring with Tourette's, and did my postdoc and a little bit of faculty at Brown University, working with the folks doing the POTS trials, which were these studies of therapy and medication for OCD. And then I had to sort of figure out how to sustain myself as a researcher. Okay, I got to get a grant if I want to.
Got to find a home or a
real
university
science
somewhere. Yeah.
Yeah. And so I was still at Brown, and I was, talking to a mentor of mine, and was I would like to really get back to focusing on Tourette's. And I know that nowadays you got to do stuff about the brain to get funded. And so he was like, okay, how about, I know someone who does this thing called transcranial magnetic stimulation, or TMS. Let me walk you down the hall. And I met my mentor, Ben Greenberg, and he was basically voluntold to mentor me. And I was fortunate to get a career development award from the NIMH to learn how to integrate neuroscience methods into the behavioral research I was doing in Tourette's. And that's really the story of where I'm at right now, fortunately. So the two big projects related to this are, one is looking just at when people get CBIT, what is it about their brain, their symptoms, their environment that predicts who benefits? When people get better from CBIT, what changed? What changes in the brain when tics change? And then can we learn better how to teach therapists to do CBIT in the most effective way by looking at how it works? So it's kind of this really mechanistic study of okay, we know what the package is, but can we pull it apart and figure out how it works?
Yeah, it's super important because I think I've read about 50% of people benefit and the other 50% do not from CBIT. So I think there's a really just untapped area of research here, is why do some people benefit and others don't? And like you said, what would predict that? And then how can we reshape the way we conduct CBIT so that more people can get that kind of outcome? Definitely want to chat more about this and also about TMS. They're both really great, areas for especially the TMS piece. I think a lot of people may not have heard of or be aware that that's something that we're researching. But while we're on CBIT, do you have any inclinations now, the preliminary data you have on what kinds of profile would be a great candidate for CBIT, and who maybe wouldn't benefit from CBIT?
I think if you talk to a lot of folks who do this clinically, a lot of us have a similar anecdotal sense, but we don't have the data yet. We're still partway through that trial. So, a big there are lots of questions we have, and, some of it have to do with like, is there sort of like CBIT is really focused on improving tic controllability. It's a pretty narrow treatment, right? And so we know from other research we've done that like not everybody can control their tics. And so we have this sense that maybe it's like enhancing something that for some people isn't quite there. And so it's like you're not going to benefit if you don't have something to build from, like a foundation. So maybe we need a different approach. So I would say that's probably one we're really interested in. And we're really interested related to this in kind of these systems in the brain that are involved in inhibition. So, a lot of what we see when you look at the literature of like, why do some adults experience a decrease in their tics why do people experience that as they're aging, like a change in their tics? And what that data mostly suggests is that it has to do with the prefrontal cortex maturing, and that's like your brain's inhibition, center. And so what it's doing is, it's not that the motor system, like that's outputting the tics, is changing. It's just that the brain is getting better at putting a brake on.
Oh,
and,
okay.
And so my hypothesis is that CBIT is promoting that, is like, we're strengthening the brake.
The brake,
we're practicing the brake, right? And we're strengthening these brain circuits that then can like tell the motor system, like, it's okay, like we can pause. So, a lot of folks will say younger kids or people with ADHD, particularly like hyperactive and more motor impulse control challenges, they tend to not do as well in CBIT. And again, I think it comes back to this, like, your inhibition system probably needs to be at like a certain place for it to be the right treatment for you.
Okay.
So I'm answering this more as like, this is still my hypothesis. We have some signals in the data that, like, from another study, that yes, it seems like there's this relationship, and that's what we're working out.
Well, then it also suggests that the same person who doesn't benefit from CBIT as a kid, if their tics last beyond their 20s, they might benefit as an adult as their brain has developed. So that same patient, could go from not getting much result to, they tried again 15 years later and now they're getting better benefits with it.
Yeah, important point, because another, a question that we got from the community was like, how do we know when the right time is to try it? Because it's really awful to do a treatment and not get better.
It's so hard though too. Like CBIT takes months and a lot of self-discipline and practice and patience. And I have to be honest, like I gave up. I was trying it this summer after 8th grade, and my therapist I was working with, God love him, he had never done CBIT before. I was from rural Indiana. He went out and bought the book from TAA on how to use CBIT for tics and for Tourette and tried to teach himself. So it was already going to be an uphill battle. After, I don't know how many sessions I had, maybe a month and a half or 2 months or so. And I was like, you know what? I had so many other things going on in life, and it was a stressful summer, and I just couldn't devote the time or attention to it that it took. And so I kind of gave up on it. But I've always been curious about trying it again, especially for some of my just like particular self-injuring tics or things that I'm like, oh, that's a tic I really would like to work on. But anyway, I've always wondered about that. Like, why was my experience not different? Why wasn't I one of the lucky ones that got that benefit? I think there's a lot of reasons it could have been, but I think it's something, to talk about. Why do people benefit? Why don't others? And how can we get the best results with that?
Yeah. And I love your point too about like, maybe it's better for certain kinds of tics. Like I have been really reflecting lately on how CBIT was developed in the pre-neurodiversity movement era, where it was more, I think the autism community has really led this nicely in sort of starting to question, like, what is the target of a treatment for?
Yeah, like why do we pathologize these things? And what's the goal?
Right. Like we know this is a neurodevelopmental condition. We know it's not, that CBIT's not a cure. And sort of, are we treating tics because they're, bothering people, or because it's bothering the person who has them? And like, what is CBIT right for? And what is the message of CBIT? We think about this a lot in our clinic of like wanting to be really careful about we're going to target the tics that bother you as the person who's coming to us for help, not the ones that bother your teacher or, or like some people are like, I don't care. They don't bother me. They're so minor, and so I also think there's this question of like, for what symptoms is CBIT helpful for, right? And, if you're experiencing painful tics, self-injurious tics that are really impacting your ability to function, that feel very distressing, I think it's worth giving it a good shot. I don't think we have to use it for all the tics a person has. I think some people burn out from CBIT because of that. And, something we're starting to look at a lot in my lab too is like, actually, when people come to CBIT, what is it that their goals are?
Yeah.
And is that what CBIT was built for? And in a lot of cases, it's not entirely. I had a patient recently who's like, I know I have tics. It doesn't bother me now. I just want to know what to tell people when they ask me what I'm doing.
Then let's
right?
talk about disclosure. Let's talk about your
exactly. Or like, so what is like quality of life issues? So, I'm of the camp that like, I think CBIT can have a lot of value for particular things, but I don't think folks should be looking at it as like, this is the treatment for all the things with Tourette's. And if it doesn't work for me, like therapy or other things aren't helpful.
Right. Well, and let's talk about that then too. Like, so let's suppose someone's tried CBIT, maybe it's not for them or they can't get access to it or whatever. They want to explore other things. I know your team is working on other treatments as well. So TMS being one of them. Do you want to walk us, our listeners, through what TMS is and kind of how a typical session works?
Yeah. So TMS is a medical device that is already in regular clinical use for adults who have depression that hasn't responded to first-line treatments like medication, and also for adults with OCD. And recently it's been cleared for adolescents with depression as well, and for smoking cessation. So it's a device that's been in clinical practice, and it's basically a hand-sized magnet that we can hold just against the head. So it's non-invasive. You don't have to be sedated or poke at all. I'm a psychologist. I don't do needles and stuff.
No needles, no blood, no internal organ. Yeah.
Exactly. Stay away from this. So yeah, it's this hand-sized magnet. And so the cool thing about magnets is that they have electrical conductivity properties. So when you pass electricity through a magnet, it creates a magnetic field around the magnet. And then if there's something that's conductive in that field, it becomes electrified, basically. So like if you have a really strong magnet and you put a light bulb in the field, your light bulb will light up. And so our brain cells, our neurons, communicate via electricity. So it's chemical changes that happen that then create an electrical signal that travels through your brain. And so what we can do with TMS is by holding it over really specific spots in the brain, and depending on how we pulse that electricity, so we can do it like slow or we can do it really fast, we can change the electrical activity in the brain cells underneath to either turn up activity. So if there's like a brain area we think isn't active enough, we can turn it up, or we can use it to turn down brain areas that are overactive. And so I think that's the first thing I like to emphasize is it really is a tool. There isn't like, and we're still working a lot on like, what's the best way to use this tool for Tourette's?
The frequency or where we target, supplementary motor area versus, other areas that we might target.
Exactly. And the area we're looking at, the supplementary motor area. And something that's been really interesting to me about TMS, particularly given I'm a psychologist and a therapist, is all of these technologies like TMS, these neuromodulation technologies, the idea is also that like what the brain, how our brains act is a interaction between brain activity, like the cells in our brain, and then the experiences we're having. So the state that we're in, like what we're thinking, what our feelings are, what our behavior is. And so there's a lot of really interesting research in the the TMS for depression space, where people started to be like, oh, wait, part of why some people seem to benefit and some don't is they're doing different things like before and after their sessions.
Oh.
And so what if we actually use TMS to sort of help boost something in the brain and then do therapy skills that really then exercise that? And so that's what we've been doing in my lab in a study we call the CBIT TMS trial. And so like I was saying earlier, this idea, right, that maybe your brain needs to have a certain amount of inhibition for CBIT to feel like it clicks, right? So we're using the TMS to turn down this overactive motor area. So kind of give the brain a better chance to be able to inhibit. And then the participants are then immediately walking into a CBIT session and practicing those skills with a therapist.
The inhibition skills. Yeah.
Exactly.
Okay.
Yeah.
Okay.
Yeah. So really thinking about kind of like, can we boost the behavioral practice by helping nudge the brain in a direction that's helpful?
You've mentioned fMRI scans. When we do things like CBIT and TMS, can you talk about how we're actually changing our brain?
That's part of the questions we're asking in my lab. So there has been no study that has really looked well at what happens in the brain.
Really?
Before
We
and
don't have
after
any
CBIT.
study on that yet.
There's like one study in 7 people. Like,
oh my gosh.
That was the original one. And so that's a big part of what we're asking now. We have the results of the first phase of this CBIT TMS study where we did look at changes in the brain. And part of what we're seeing is that we do see this change in the connection between the motor area on the surface of the brain and the motor area deep in the brain in the basal ganglia. That seems to become reduced as people go through CBIT and through TMS. And so the idea is we're probably turning down this overactive motor process.
That makes sense. I mean,
which makes sense.
The goal or part of the,
Yeah, exactly. But we're really curious too, like I said, about this inhibition circuit as well, and kind of trying to understand better, like, how do these two work together?
Yeah.
So we have a lot of data we have to look at. It's kind of where we're at.
And then even more, to get further, there's even implications around, like, can I change my brain with things like conscious breathing or redirecting my attention and some of the other coping tactics I may use. Lately I've been focusing a lot on just throughout the day trying to do kind of the breathing in thirds and like really focusing on my breathing more so as a grounding and kind of grounding exercise and to relax. But it does also help my tics. And, I wonder if you get in the habit of that, I know people who practice that kind of breathing regularly, that way of breathing sort of becomes the norm for them over time. It's less of an intentional, I need to slow down and breathe. You're kind of always or oftentimes in that sort of state. Yeah, I wonder if you're doing longer term benefit to your brain when you practice those things.
I think you bring up this important question, this sort of idea that like there are multiple ways that you can create similar changes in your brain, right? I can change the motor area of my brain by learning piano, by learning tennis, by, So part of why I am really interested in this question of what happens during CBIT is not, I care about CBIT, but part of me is more like, if we understand what is changing when people experience a difference in their symptoms, then we can start to hone in on like, what are all the ways we can access that?
Yeah, exactly.
Right? And can we access
what it is?
And from working with lots and lots of patients, like I think it's different for different people. Like for some people, it might be TMS really is the way. For some people, it might be CBIT. For some people, it might be breathing. For some people, it might be, whatever. It's more like because we don't know the why in Tourette's of like, why are symptoms getting better when they do in people? Once we know that, I think it's going to unlock a lot of potential ways to get there.
I think so too. And then, then we bring that to the patients in terms of treatment options and what can be, what all they have at their disposal to use and see what works for them. And hopefully less of a kind of like shot in the dark approach or trial and error. I hope we can get to a place where it's a little more kind of systematic and formulaic in how we determine, all right, maybe try this, or you seem like this kind of profile, maybe CBIT would be a benefit to you, or TMS or something else. Great work that you're doing and your team. So I'm excited to see the paper when it comes out on this and the other areas we discussed. I know you're also doing research around OCD and anxiety. Any cool studies there that are in the works you want to share?
Yeah, we have so similar to the CBIT TMS study, we have another study in OCD. We call it the NEXT study. It's with my good colleague, Kristen Menito at Brown. And we are kind of a similar principle to what I was talking about before about like, can TMS help boost how well therapy works? We are testing a combination of TMS and exposure and response prevention for OCD.
Oh.
So the idea there is that we know from a lot of research we've done that one of the big reasons that people don't benefit from ERP, and for those of you who don't know, it's in a nutshell, ERP is like gradually doing the things that are scary that OCD doesn't want you to do. So you expose yourself to those situations while doing response prevention, which is inhibition of compulsion. So you kind of, it's like you get in the situation and you stay in it until you naturally feel better. It's this idea of habituation that we all are wired to do. So one big reason that people don't benefit from ERP is they can't inhibit their compulsions, right? So we're getting back to this common theme of inhibition, right? And inhibition is hard, especially when we're really anxious. The more anxious we are, the worse the brake system in our brain works.
No kidding.
We're all less regulated when we're anxious and stressed. And so we're using the TMS we're actually trying two different spots on the brain to see, can we kind of turn up an area that helps with inhibition and can we turn down an area that's like more of the motor activation? And then so similarly, people are getting TMS and then going right into their exposure session. So I don't have any results for that yet to share. We're still recruiting and collecting data, but we'll be able to look at how it impacted exposure therapy, how it changed the brain, if it did. So, another exciting way to kind of help all these co-occurring symptoms that come on.
And a lot of the same population overlap, with Tourette and OCD. Now, can patients participate virtually in the OCD trials you have, or is that you need to be in Minneapolis for?
Yeah, so for both of our TMS studies, and those are for 12 to 21-year-olds right now, those are both, you have to be able to be in Minneapolis for about 3 weeks. Because it's hard for us to take pictures of your brain and do TMS if we're not.
Well, TMS is like daily, right? You get it done daily for like 15 minutes or whatever it is.
Yeah, we do it every day for 10 days in a row, 10 business days. And so I kind of think of it as like a boot camp version of CBIT. It's like we're kind of helping create a lot of what we call neuroplasticity in the brain all at once, like giving it a big boost. So that CBIT TMS study is only in Minneapolis. The one with the OCD study is also in Providence, Rhode Island. And then the one that is just CBIT is also in San Diego. So depending on, if folks are interested, and we're also really happy to just help point people in the right direction if they're just like, I just need a direction.
No, I bet. It's sometimes easier just to, call, and you guys are also a great referral source. Well, I mean, I first met you at the TAA conference a few years ago in Minneapolis and saw, you were doing some kind of video study. They want to record my tics. Sure, I'm at a Tourette research conference. I guess I'll participate in Tourette research. Seems like the thing to do here. And so that's how I got acquainted. So I think my point is that, if you're going to any of these events, you may run into people doing this kind of research. You can get involved that way. If you go to TicCon or, any kind of national conference on this, you may find yourself in a place where you can get started with some of this, at least the video one where, we just need a few minutes of your time.
thank you for sharing that. Like, I want to highlight how impactful, like, your decision to participate actually is, because we had no data showing we could do this. And by having literally, like, I think it was like 15 or 20 people at TicCon participate, we were able to go back to people at the NIH and say, like, we think we can now do this in 1,000 people. And they were like, okay.
Wow.
Right. And we would have never been able to do that without, our participants being willing to, like, help give us that initial boost. So
wow, that's such a powerful story.
yeah.
And I'm glad it had that. Like, I'm thrilled to hear that. Yeah, I mean, you went to a great place to find people with Tourette, and I'm sure I gave some very high quality data, because I was like, I mean, we're all primed. We're at the Tourette conference. All of our tics are like going a mile a minute. So I know you got some Michael's pure tic, frenzy on the video there. But I was feeling very, very, very ticky that day. But anyway, no, definitely note out for all of our listeners to get involved. It's also a great way to build your community and not just to take part in research, but to meet other people with this condition and other, co-occurring conditions. So when you think about people diagnosed with Tourette, especially younger people like children, and I imagine you see a lot coming into the clinic around this, is there a piece of advice you find yourself giving most frequently? And of course, I know it's idiosyncratic and every case is unique and specific, but any kind of general piece of advice you would give to either the parent or to that young person that was just diagnosed?
That's a great question. And I'm a clinician scientist at heart. So I'll tell you what I like to say based on our data. Also, I really like to focus on helping folks understand that we know a lot about what's happening in the brain when you have Tourette's, and we understand. And that a lot of the brain systems that are driving tics are the same ones that are driving the ADHD, the OCD. It's really one thing. And that having tics doesn't mean anything bad is going to happen in your life. Like, you could still be a perfectly happy, healthy, successful person, and sort of thinking about your relationship with your tics is really important, and how to live your life with your tics and not have your tics live your life for you. But I really do think this education and sort of just demystifying for people that, like, no, you have a thing and we actually really know what it is. And what we've found, we've actually looked at some of this data is coming out soon in our CBIT studies, how distressed patients are. We ask them every session, how much distress they're having about their tics. And the biggest change we see is after the first session. And then it basically flatlines. And what is that session? It's just education about tics, the opportunity to normalize it, to, like, understand that, you're not a quote unquote weird kid. Like, you have something that we get.
Yeah, it's like you found a place that understands you, and you can talk to them about it, and it's safe, and
exactly. And
makes
so
a lot
to
of
me,
sense.
I'm like, that's it. It's like, it's just the education and demystifying it, and the relief that, we got it. Like, we got this. We know what we're doing.
We do, and I think by addressing it where it does cause challenges in our lives can enable us to really make the most of the superpowers that it brings too.
Oh,
So
yeah.
I love that. Have you found it? Yeah, have you found anything in your research around that, like the brisk reflexes, musical abilities, any kind of, what are our superpowers in our community compared to just like general population?
Yeah, I think there are definitely so many recurring talents that we see, like a lot of great athletes, musicians, and we know, so part of what's happening in Tourette's and in OCD, kind of these disorders where there's a lot of repetitive behavior. There's this system in our brain that is responsible for us learning a new, like, motor sequence, and then what we call habitizing it. So there are kind of these two different systems. One is sort of like, okay, I'm learning the new thing. And then once it's like, okay, I got it, I'm moving it to habit. So think about, like, learning how to ride a bike or, like, playing a new instrument. Initially, it's very, like, high conscious effort, because you have to really think, okay, where do my hands go? How do they go? And with repetition, you don't even think about it anymore. That's your habit system. And so one of the superpowers is that habit system is really, really strong in people who have Tourette's. And so people with Tourette's are usually better at learning something that involves motor actions more quickly, habitizing it more quickly. and then making these subtle adjustments. So like things, again, like any kind of like physical, like learning a new instrument.
I'm wondering like choreography and fine motor skills or
yes.
Okay.
Yeah, kind of that, like I think for people without Tourette's, I'm like it takes more times of practice, whereas people with Tourette's, it might only take a couple, and then you're like, I got it. And I think that's really cool.
I always found with sight reading and music, there was like something, and I have no data or anything on this, but I just felt subjectively that I could just give me a piece of sheet music that I've never seen, never played before, and ask me to start at the first measure and start playing. And I found it, I was a percussionist as a kid, and I found I could make it to the end with very minimal errors. And it was like something about just seeing, I could read the music and just play it for the first time without practicing or thinking about it. And I don't know, it felt very Tourettic. It was like something about my brisk reflexes or something in there. My brain, I saw the note and I just knew to hit the drum, and in that way it just kind of, I don't know, it was very natural for me. That was how I personally felt like there was something. I can't explain why. It just I can guarantee that it had something to do with my Tourette's. Like that was just,
oh my gosh, I have to say
I was a good drummer.
I'm like so excited about your example because I started taking drum lessons
because I've
like always wanted to, and then I turned 40 and I was like, I am gonna do it. Like I'm just gonna learn. Now's the time.
Absolutely.
And so I've been learning the drums, and let me tell you, that is not my experience as someone who does not have Tourette's. The amount of time and energy I spend trying to be like thinking about like, okay, what is this limb doing and what is this limb doing and how do I do this and how do I do that? It's so effortful. And so it's really cool to hear your story of like, oh no, that was, and I think that's a great example of the superpower.
For me, it was, I would say drumming was probably where I noticed it the most of that, really just like feeling like it was helping me and empowering me in a way. To your situation, I think I noticed a difference between like drum set versus snare drum. I think snare drum can be good for just kind of getting beats and rhythms and stuff without the like syncopation of like your leg doing one thing and your hands doing something else. Maybe, I actually preferred snare drum. I don't know, but that was always my preference. But anyway, though, I know a lot of percussionists with tics and Tourette, and I don't think that's just a coincidence. I think there is something there that many of us find just kind of an affinity to it. Something feels very natural about the syncopation, about the way it uses our senses, our fine motor skills, the reflexes we have. Could be a lot of things, but I always encourage young people to find some kind of, if you're looking for an activity, like rhythmic sports are great. I know like swimming, running, things like that have been recommended to people with Tourette. Give it a try. It doesn't dictate your life. You don't have to do this, but I think as a young person, if you can find something that you're naturally good at, that works wonders for confidence and just everything down the road. So definitely something to give a try.
Yeah, exactly.
Well, Dr. Conelea, it's been great having you on the Uptick.
Yeah.
And I'll have to have you on again. This was wonderful. And to our listeners, we'll put some notes in the description for this episode so you can check back and find her lab and research and some of the other things that we discussed. I hope you all have a wonderful rest of your day.
Thank you for listening to The Uptick, brought to you by the New Jersey Center for Tourette Syndrome and Associated Disorders, empowering you to stretch the boundaries to live your best life.